Bottom line is the College Board just released an update within the last 20 minutes, and I've been reading through that, and that's where I want to start and maybe finish for today. Main thing is I want to do what's going to best help you, so I'm going to consult with you through your feedback on this platform, through Remind, through the YouTube feedback, all the different ways that I can get your feedback. But essentially, big picture here, what's happening is that you're going to have an opportunity to either cancel your test with a refund, or go ahead and take your test, and it's going to be online at home. It's going to be a 45-minute. I'm not exactly sure yet. I haven't read through everything to understand exactly how the FRQs are going to go, if there are going to be FRQs, but what I'm gathering is a 45-minute at-home online test, and it's only going to cover the first 7 units. Now, we've been counting units all differently all year. I understand how the units have gone the whole time. I've been meshing the way the units used to be with the way the units are now and all that, so nothing for you to worry about there, because I have you on track. And what this means, though, is that you're going to be tested on the units we've covered so far, and you're potentially not going to be tested on what we're even doing now, acid-base equilibrium and thermodynamics. So that changes things, but there's a couple things to keep in mind here, because
You're good.
Because this is what the College Board is adapting to. They say they have support from colleges to accept the exam score, even though it's modified. However, there is still the reality that you won't have covered, like if I stop covering material, which I'm willing to do. Of course I'm willing to do that if that's what is the best thing. Or I might do 2 streams where I just start reviewing. Like I just start having review sessions, and those who aren't going on in chemistry, aren't doing anything related to, and I don't mean just chemistry, but like you're not doing anything in the medical field, you're not doing anything that's going to require any ongoing chemistry coursework later. If you know, that group could just watch review sessions, and then the other group I could continue doing what I'm doing, because even if you're not going to be tested on it, it's still the reality that if you were to take this class in college, these topics would absolutely be covered. So I have a little bit of uncertainty in my mind on that, but it's really up to what you all want. But if you look at the document that Zachary has on the screen there, it talks about they're providing free remote learning resources. They're investing in the development of a new at-home testing option. So the traditional face-to-face exam administration for this year will not take place. And so then it says some students may want to take the exam sooner rather than later while the content is still fresh. Other students may want more time, so for each AP subject there will be 2 different testing dates. The full exam schedule, specific free response question types that will be on each AP exam, and additional testing details will be available by April 3rd. So that's still to come. There's already a sketch of what they know so far, and we'll get to that as we come down here. So it says students remain eager to take the AP exams. It says that they surveyed 18,000 students, and 91% said they want to complete the exam. So it says we'll continue to support students with free resources through exam day, and while we encourage students to wait until closer to the test date to decide, any student already registered for an exam can choose to cancel at no charge. So of course that's completely up to you and your family. So here's what's happening moving forward. The AP program will invest heavily over the next month in the following ways. For the 1920 exam, students can take a 45-minute online exam at home. AP curricula are locally developed. To be fair, only topics and skills most AP teachers and students have already covered in class by early March. And so we're there. We have covered units 1 through 7. Units 8 and 9, like we're in the College Board Unit 8 right now. Which is how it's been every year for me. Like that's the normal place where people are. It says colleges support this solution and are committed to ensuring that AP students receive the credit. Students will be able to take these streamlined exams on any device. We recognize the digital divide could prevent some low-income and rural students from participating, so they're working with partners on balancing that out. Test security is a concern. They're saying that they have a lot of test security things in place. But then if you go down to the course-specific exam information, and you see the grid there, and you scroll down. So if you look at the headings there, exam questions will cover and will not cover, exam question types, exam date 1, exam date 2. The only thing we know right now, because the rest of this information will be available April 3rd, the only thing we know right now, if you scroll down to chemistry, go ahead and on the left, keep scrolling down to chemistry, Zach, go, right there. You see the only thing that they know right now about chemistry is that the exam will cover units 1 through 7, which is everything we've covered prior to spring break. What it won't cover is units 8 and 9. Now this is, again, what I'm saying is I'm a little bit torn on this. It would be extra work for me, but I would be willing to do it, to have kind of 2 tracks where if you still want the new units and review, even though you're not tested on the new units, to kind of complete the course, I could look at doing that. Otherwise, we could just shift all the resources to just having review sessions on units 1 through 7, because by the way, there's a lot to review. And you wouldn't have had very much review. Now you can have a lot more review time, just even on your own, with or without me. So if you, that's all that's known about that for chemistry. So then Zach, if you keep going all the way down, past the grid. Yeah, okay, wait, go up a little bit. So it says, beginning on Wednesday for instructional support, March 25th, which is just next week, both you and I, students and teachers, can attend free live AP review courses. No, I'm not important enough to be one of those teachers that's doing those live review courses. But these are designed to work along whatever we're doing. They'll be recorded, they'll be available on demand. So, I mean, basically, you're going to have a lot of resources, and you're going to have to decide whether or not the AP College Board website resources are helpful. Obviously, I could just quit doing what I'm doing, and you could get it all from the College Board website. It'll focus on reviewing the skills and concepts from the first 75%. There will also be some supplementary lessons covering the final 25%, which is what I've been talking about. And then it just talks about all the AP classroom resources, and I will certainly be, over the weekend and the next week, kind of trying to organize my mind around all of the, there's just so much, there's so many tools out there that I will, if it's something you want, I'll kind of organize review sessions so you're not figuring everything out as we go. But understanding you're your own person, you can just do what you want in terms of preparing yourself for the exam if you're going to take the exam. Because understand that for CFISD, For your AP classes for CFISD, they're going to have you log into Ingenuity, but they're just going to be assignments there. They weren't put there by me. They weren't put there by the College Board. They're going to be put there by whatever CFISD decides. And I can't even see what they're putting in there until Monday. So that's a whole different thing. And you're definitely looking into that, logging into that for all of your other non-AP classes. The lesson I had today, is continuing on in Unit 8. And like I said, Unit 8 and 9 are now not going to be on the test. Officially, is what they're saying. So, we could end it here and take all this in and digest everything and figure out what we're going to do. Or I could, I don't know what time it is. Have we spent 10 minutes talking about this? 15 minutes? 10. Is anybody online anyway? Mm-hmm. So, do we have any feedback?
No feedback so far.
Okay. So, I think the people that are online, do you have any feedback for me? Do you want me to go with an ongoing lesson, or just wait here, pause for the weekend, and regroup? What are your thoughts? I'd be asking you if you're in class right now live. Do we have? Yeah. Okay. So I think
say this sucks.
What? Oh,
that's one of the comments.
Okay. I think we'll go ahead and end it here, and say we're figuring everything out here. What do we got?
Say we can stop for today and do reviews next week.
Yeah,
that's one of them.
All right, so we're going to stop, and I encourage you to look at the College Board website, read up everything that I was talking about there, and if you could, through Remind, just reach out to me on Remind or any of the other hosting opportunities through Twitch or YouTube, and let me know your thoughts on how you would proceed.
We have 4 more people coming in. They want to continue with 8 and 9.
Okay.
So we could just do the continue and review.
Yeah, I mean, that's an option. Right. So they want to do that right now, or what are they?
I don't.
Yeah. So, challenging times, but we're going to adapt, we're going to adjust and adapt, and we're going to prevail. And I'm pretty surprised that they're going to do a 45-minute test. Now, there's 2 ways to think about that. You can think, well, not only is it a 45-minute test, it's a shortened test. 2 ways you can think about that. You can think, well, that makes it a lot easier. Or they could make it a whole lot harder by making the questions even harder than they already are. So we can't, I really don't think we can just immediately say, oh, well, since I can do it at home and since it's online in 45 minutes, then it's going to be so easy. I don't think we can say that. And I don't think we can say that it's going to be graded that easily either. So we still got to prepare. So
looks like most people want to continue.
Okay. All right. Well, we can jump in here, and I'll at least finish up what I had planned for today. Then I'll do that. So I'm gonna put this away and get out that. So For today, where we were was in the big notes. In the big notes packet, page 13. Page 13 on titrations and titration curves. So you should already hopefully understand that titration is a quantitative method. We don't have a solid that we're forming, so it's not gravimetric analysis where we have a solid produced and we can weigh that solid and we can analyze it for purity and things like that. This is more of a quantitative analysis where we do a titration and we, let me get some markers here, where we figure out moles based on neutralization. And so, just like it explains there, it's an experimental technique used to perform a neutralization reaction, and the accuracy of the glassware and the accuracy of the volumes is critical. When 100% of the acid or base has been neutralized, then we talk about being at the equivalence point. And at that point, there's a rapid change in the pH, and these can be, there's different scenarios that we can look at. So if you go down, Zach, on the, let's look at the first couple of graphs there. So if we have a strong acid with a strong base, again, if we look at a graph here, strong acid, strong base, if we are, if you think about the titration happening over here, where we have our burette, okay, and we're dispensing this, this is our graduated burette here, and we're dispensing. So remember, in here is the titrant, and then in our flask or beaker down here is our analyte or titrate, our titrant and our titrate. Can we see that okay? If we're starting with an acid in here, if the titrant is an acid, or excuse me, let's reverse what I want to say. If this inside the burette is a base, which is what you did when you titrated in Chem K or L, and in the flask you start out with some acid, okay? What of course we're doing is we're measuring the pH in here. If we put a pH meter in here, we're starting with what the original pH is of the analyte or the titrate. So if we're titrating a strong acid with a strong base, we're starting at a low pH, which is why on that first graph, you can just look at your sheet there, that first, if this is pH and this is the volume of NaOH or the volume of base added, okay, we already have a certain amount of acid. We know its molarity. We know its volume, excuse me. We know its volume. We know the volume and molarity of the base. But if we're starting with an acid here, then of course the pH is going to be low. It's going to be very low. And so and then this one shows, the equivalence point happening at 25. So we know if this is strong acid, strong base, the middle of that is going to be here. So we're going to come up here and it's going to look something like that. Where the equivalence point for strong acid, strong base is going to happen right around 7. Right around 7. Now, of course, if we're going to do weak acid with a strong base, that second graph, the one on the to the right, the graph to the right of strong acid, strong base. If it's a weak acid, then its pH is a little bit higher. It's not as acidic. And the range here where we get to the equivalence point, the range decreases. So weak acid, strong base, we're still going to end with a high pH because we're adding a strong base. But it flattens out a little bit more. This isn't as steep if you look at your weak acid with strong base. And then Zach, if you go down to the bottom to strong acid with weak base, strong acid, again, if it's a strong acid, we're starting low, but it's a weak base, so that means then that it wouldn't be an NaOH. If it's strong acid, weak base, because it's a strong acid, our pH is really low, and we taper off, but then if it's a weak base, we're not going to go as high. And this actually is short. I made that too. You can just, it's best to look at the graph you have on your page there. And then weak acid, weak base is your narrowest. Now, when we titrate strong acid, weak, strong, weak, we can use indicators. When it's weak, we can't really use an indicator to figure out where the equivalence point is or where the end point is. So speaking of that, if you scroll down, Zach, on the next page, most acid-base titrations, sodium hydroxide and hydrochloric acid are both colorless, so when you're adding them together, they're colorless with colorless. We can't really tell anything that's happening, which is why we use an indicator. And so the indicators are chosen based on where they change color. And so it is definitely helpful to know, the general range of these, but on a test you wouldn't be expected to have those memorized. But phenolphthalein is often used for weak acid, strong base. So a lot of what we do in our titrations are just those. We use phenolphthalein because we're titrating with sodium hydroxide, and in here we might have acetic acid or some other weak acid, where because the pH change happens in the basic area, right? Because weak acid, strong base, the change is going to happen in the more basic range, which is what happens with phenolphthalein. And like at the bottom of that, if you keep going down the page a little bit there, keep going. So it says for weak, just like I mentioned, for weak acid, weak base titration, there's no sharp change. So no indicator will really do it there. We need a pH meter. And then an acid, like if we're going to titrate with H3PO4, phosphoric acid, this has 3 hydrogens. This is going to bring 3 hydrogen ions, so we would have technically we'd have 3 equivalence points, and the graph would show that. All right, so before we get into, well, actually there's one more page. Let's do that. So this is very good to see here. This is what we were doing with our sheet yesterday. Okay, if you're going to combine a strong acid with a strong base, then the equivalence point should be right around 7. The pH should be right around 7. Example of the salt formed there, NaNO3, sodium nitrate. All right. Again, sodium nitrate. The sodium would have come from sodium hydroxide, NaOH. The NO3 would have come from HNO3. Strong. The sodium becomes a spectator ion, not really doing anything because its contribution to the overall pH is less than what distilled water would do. Same thing here, nitrate, its contribution to the overall pH is less than what water would do. So because both of these have no impact on the pH, then what's the pH of that solution? The pH of water, because they have less impact than water does. Now, if we do a strong base with a weak acid, okay, the pH is going to be greater than 7. If you go down just to that, like focus on, yeah, that strong base, weak acid, pH greater than 7. And it has this Na plus and then CH3. Now really, if this is plus and this is, like, the reason it's written like this is that this is really an ion. So it doesn't really stay together. You could really do that here too. I mean, it doesn't really stay together, it's an ion. Again, where did this come from? This came from NaOH. Where did this come from? HCH3COO. And this is not one of the strong acids. So this is from a strong base, weak acid. If you mix a strong base with a weak acid, you're going to get a result of a basic salt. This is going to be a basic salt. And so its pH is going to be greater than 7. Do we have anybody on still?
Yeah. No,
okay.
This is the light. This is Carlson.
We have a pH greater than 7. So that's what it's talking about with the second example there in this grid on page 15. Strong base, weak acid. The pH at the equivalence point is going to be greater than 7. Like the moles at the equivalence point, moles equal moles, but the fact that we are mixing a strong with a weak, of course the strong overpowers, and it shows you the equation there. So from yesterday, let me write up the equation there again. This is critical to understand with these here. So this ion is not what's important. This sodium is not contributing to the overall pH of the system. Okay? This one is. So we have our ethanoate or acetate ion in the presence of water. Okay, it's going to be in equilibrium. Now, again, this came from an acid, so this is the anion from an acid. If it's the anion from an acid, it's acting like a base. This is acting like a base. What do bases do? They accept protons. So it's going to take a hydrogen from here and it's going to become the acid again. HCH3COO. It took a hydrogen. And then what's left of this after a hydrogen is given up, we have OH. Okay? Again, this completely falls in line with the fact that its pH is going to be greater than 7. That looks like 2 7s there, but the pH is going to be greater than 7 because look what's in solution. It's going to be greater than 7. Look what's in solution. What we have in solution is a conjugate base from a weak acid. This is the weak acid. So we have conjugate base and its pair, but we have hydroxide. When you see hydroxide on the right side of an acid-base equilibrium, that means it's basic. This is weak, this is weak, this is strong. So this dominates the pH of that system. And when you know the Kb value, if you have the Ka or Kb value of either of these, you can figure out what the pH actually is, but it's not 7. It's not going to be 7. because we can find the hydronium content there. Okay, so that's how those. You can look through the rest of those and see those. Then I'm not going to do too much here. But let's try at least the example of it. So Zach, if you can go to that worksheet, I gave you in Google Classroom, I uploaded this worksheet on titration simulations, and it gave you this link, HTTP, bit.ly, so forth. So what I'm going to have Zach do is he's going to go to that actual link, and we're just going to step through quickly how to work this, and then you can work this on your own. So go ahead and go to the website, Zach. Hold on. Something wrong?
Yeah.
What's up?
There's just somebody trolling the chat.
Oh. Yeah. Well, yeah. So when you click on the link, well, actually, I think we need to step through it and show them how to do it, like I showed. Yeah. So this didn't used to happen. Like when I vetted this before the break, it didn't go to this guy's website. But obviously, this is the guy that set up this simulation. So under his name, if you follow what Zach is doing here, under his name, you're going to click on Computer Simulations. And then it's going to take you to this Chem Demos page, and you click on Acids and Bases. And then it's going to have you go down, then you scroll down to the one I want, which is this right there, Acid-Base Titration Computer Simulation. You click on that. Now, if it brings you to a page where it says agree or disagree, you may have to disagree for it to keep going forward and get to this page. It used to, like I said, I don't know what happened with their link, but when I tried this before the break, it just went straight to it. It didn't do all this, but you kind of got to wade through all this. So then you got to click on that again, acid-base titration computer simulation. Ultimately, you're going to get here. Now, what I'm going to do is read from the worksheet. Like you should have the worksheet in Google Classroom, and then you have this as well on your screen, and it says go to the computer simulation and select the following. So you're going to select strong acid, strong base. So click on that one like you just did, and then it says fill the burette with base. So number 2, it says fill the burette with base, and then number 3, click on number 3. It's over on the side there. Choose HNO3 as the acid. It's the third one down, and choose KOH as the base. It's the first one up there, and I'm just reading the directions as they come on your sheet. And then number 4, it says select the indicator and select phenolphthalein. And then the computer will automatically assign a molarity and volume for the acid, and you see that down there, like the one we see on our screen right now. It's going to be different for you. Every time you do it, it'll be different. But I see 0.1954 molar, 25 mils, right? So that the computer selected that, all right? Using the slider, add 10 milliliters of the KOH. Just go up to 10. Go back to 10. Right there. Okay? And that says, write a chemical equation that illustrates what happens when HNO3 reacts with KOH. So, while that's just paused on the simulation there, the chemical reaction when HNO3 reacts with KOH, these are both aqueous, is that the hydrogen ion separates from the nitrate and the potassium ion separates from the hydroxide. And so we're really going to get KNO3 and HOH, or which of course this is water, but it's often written like this for acid base because we have the hydrogen from the acid, the OH from the base. But this is also aqueous. this is a liquid. So really what we have, if we skip the complete step and go to the net, well, let me not skip it. So really what we have is this, H plus NO3 minus plus K plus OH minus goes to K plus NO3 minus plus H2O. That's what we have. And all of these are aqueous except this is a liquid. And so now this is your complete. For your net, since potassium is on both sides and nitrate is on both sides, that means they are spectators. They're not participating in the reaction. What's really happening is the hydrogen ion reacts with the hydroxide ion to make
They
water.
can't see that. They can't see the H2O.
Okay. So they can see down here?
Yeah.
So I'll just rewrite it down here. So this is the hydrogen ion with the hydroxide ion makes H2O. That's the neutralization reaction for a strong acid with a strong base. If it's a strong acid and a strong base, it doesn't matter which strong acid or strong base it is. If they're strong, this is always the neutralization reaction. That's what you would write in number 1 on page 1 of this worksheet. So then it says, and I'm not going to do this, then it says titrate to the endpoint. Getting the exact endpoint requires care, adding drop-wise, and will be reached when there's a permanent pale. So this is simulating a titration. So if you, let's jump it. Let's say that we can jump it to 15. So go ahead and add 15 in there, and let's just hope. Let's hope we're okay. Okay, yeah, go back to, yeah, that's fine. 15 is fine. No, you can't go back. Now start adding it drop-wise. So you're just clicking that, and yeah, just keep clicking it. So because we don't know what the molarity is, we're adding it drop-wise. This could take a while. So what's going to happen is that's going to eventually turn pink, and when it stays pink, we're at our endpoint. It just might take a lot of clicks. So because we don't know, okay, now slow down now. Okay, now if you're watching what he's doing on your screen, you're seeing that it's turning pink and then clear, pink, clear, pink, clear. And if you remember doing titrations last year, that's what would happen, is it would go pink, you'd swirl it, it would go clear, pink, swirl, clear. And so eventually here, it's gonna stay pink, and you can't go, like, you can go faster than you are, but don't go as rapid as you were before, because as soon as it's pink and stays pink, we're done. And we gotta do some math at that point. So I'm going to let him do that until I'm going to erase the board. So as soon as it stays a pink, don't go past that point. And then while he's doing that, the table, it's got molarity of acid. So the table, it has molarity of acid, volume of acid, and volume of base. So this is in a grid here. And this is just from what we're doing right here. Yours is going to be different, but the molarity of acid is 0.1954. The volume of the acid is 25 milliliters. The volume of the base we're figuring out right now. And the trouble is with this thing, we don't know what the molarity is, so we don't want to overshoot, but it's requires patience. So the volume of the base is going to be when that stays pink, and then to figure out the molarity, calculate the molarity number 4, I'll put that down here. Again, that's going to be the molarity of the acid times the volume of the acid equals the molarity of the base times the volume of the base. Zach's already like, give me a break. I did this earlier, it took a long time to, but I can start putting in that here. So the molarity of the acid is 0.1954. Now the volume I can leave as milliliters because I'm going to have milliliters over here. That's going to be 25. And we got it. Way to go. So the molarity of the base is what we're trying to figure out. The volume of the base that he added is actually 20.14 exactly. 20.14. So this number is 20.14. And so now this is just algebra. So the molarity of the base is going to be, and I'll get my calculator out, and we'll do it right here to get a number for him to put in there and see if we did it right. So we're going to take 25 times 0.1954, 25 times 0.1954, and then we're going to divide that by 20.14. And we get 0.2425, which is really 0.2426. So 0.2426, let me verify that, 0.2426, yeah. So put that in the, wait, put a 0 in front. 0.2426 and push OK and see if we get A, and it says we're right. So, that's how you do number 4 on that page, and then the next page on your worksheet says calculate the pH of the acid before any base is added. Now, we can calculate the pH very easily because it's a strong acid. If it's a strong acid, then we can just use pH equals the negative log of the H plus immediately. We know what the H plus is because it completely dissociates. So that's just going to be the negative log of 0.1954. 0.1954. Now, again, remember, when you do this on your computer with your simulation, these numbers are going to change because they randomly generate. But for my example right now, we can take the negative log of 0.1954 and we get 0.709. So the starting pH, before we added any base, at the beginning, the starting pH was 0.709. So then it says to draw a graph. And this is the volume down here, volume of base added. And this is pH. Well, you know that you would start at, like, if this is 1, then you're starting just a little bit below that at 0.709. So you would be starting a little bit below. But because it's strong acid, strong base, you know that pH 7 is where the line is going to be, right? But in this case, so this is like if you had to do it on your own, this is how you would start. You know the pH is 0.709. So I'm starting below 1. I know my equivalence point is at 7 because it's strong acid, strong base. And I would draw the graph, okay? But in your case, you can actually just click on graph. And it shows you the graph right there. Now this has a very long range of where, when you, of basically a steep pH change right in the middle there, but that's all you could do is give a general shape, unless you plotted more points and got more data. Okay, So then the directions tell you to do a second one. We're not going to do that. You can do that on your own. But that's how you manipulate that graph. So big picture here. If you're going to keep, if we're going to keep going with these sessions to move forward with Unit 8 and Unit 9, then you would continue in the main packet where it says Topic 8H, Introduction to Buffers. And you would read through that. Really, you could read through the rest of the packet. There's 4 more pages there. And that's where we would pick up on Monday. And it's got a bunch of tasks in that section. And then I have more work that I would assign through either Remind or Google Classroom. I'll upload some more work to go with buffers, because buffers is a big, it may only be 4 pages in the notes, but it's a significant part of acid-base equilibrium. So if you're continuing with Unit 8 with me, and that's what we do, read through those notes, do those tasks, and I'll probably upload a few more things. I also said I would populate Mastering Chemistry, which I can still do. Understand, none of these things are really going to be graded. Like, you're not getting any grades for this stuff. This is only to keep you on track. But the bigger news, of course, is that College Board changed everything. It seems like they have a pretty organized plan moving forward. I would encourage you to go to the College Board website, read the whole update, and try to understand what they're saying. So I think that's it for today. Do we have any questions we need to answer?
Not yet.
Not yet. Okay. So we can stay on for a couple seconds here if you want to type in a question before I go. Otherwise, stay safe. I hope you have a good weekend, and I'm going to sift through all the stuff that I got from college, that we got from College Board. It's public knowledge, but I need to try to fully understand it myself and make a plan for review sessions moving forward. Plus, the district is going to have everybody start logging into Edgenuity on Monday. Anything coming? All right. That's it. Have a good one.